it's time for one more thing that you can do with references, and that is returning references. Now, just like when you pass a value uh, from the main function to another function, when you return a value from that function, you're really returning a copy of the value. Once again, for the basic built-in types, this isn't a big deal, but it can be a performance drain if you're returning a very large object. And in that case, returning a reference is an efficient alternative to that. We're going to demonstrate this using the inventory referencer program. This demonstrates returning references. The program displays the elements of a vector that holds our hero's inventory, and it displays those elements by using returned references. Then the program changes one of the items through a returned reference. So let's go ahead and get started. I've got my new text document, and I'm going to save that. We need to create a folder for week 10. Okay, so I'm going to save this as inventory referencer.cpp, and I can begin my introductory comments. We're calling this inventory referencer, and it demonstrates returning a reference. Okay, my include files, I need iostream, and since I'm going to be doing a vector of strings, I need string and vector. Give a directive that I'm using the std namespace. And now I'm going to go ahead and define I'm going to declare my function prototype. And this function prototype returns a reference to a string. Okay, so this is a reference function. It's a string and then the ampersand sign. Ref to element. The arguments that it will call will be our vector, which is a string type, but we're going to call a reference to that vector, and we'll call it inventory. We're also going to send an integer called I. So now we'll go ahead and open up our main function. We'll go ahead and define our string vector called inventory and put some items in that. Push back sword, push back armor, and push back shield. Now, we're going to display a string that the returned reference refers to. So we'll see out sending the returned reference to cout, and then we will cout whatever is returned from ref to element inventory 0. What this will do is it will send to ref2element our inventory vector and then the integer 0. The next thing we want to do in our main function is assign one reference to another, and this is an inexpensive assignment. Assigning the returned reference to another reference it will define a string reference called rstr, and we will set that to ref to element inventory I. Actually, no, that should be inventory 1. And then we'll send the new reference to cout. So we'll cout rstr, and then 2 line returns. Now, I actually want to go ahead and skip ahead a bit. Rather than doing the rest of this code as the book shows it, I think it would be useful to go ahead and do our definition of our function so that you can see what's happening. So I'm going to just put in a couple of blank lines here and then close my main function. I'll come back to here later and fill in the rest of our code. So now I need to go ahead and define my function, and it's a string reference function called ref2element, and it receives as its arguments the string vector reference that here we will name vec, and then an integer that we will still name I. And all this function does is return vec I. So vec I, remember when we call the function, we're calling here inventory 0. Okay, we are calling ref2element, and for our arguments, we're sending the inventory vector, the entire vector, and then we are sending the integer 0. Okay. Now, yes, this is our entire vector, but we're sending it as a reference because we declare that as a reference in our prototype and in our function definition. So we're not actually sending a copy of that particular vector. We're sending a reference to that vector. And then the 0, this will get used down here when we return vec I. Remember, when we're dealing with vectors, if we return the name of the vector followed by an integer in square brackets, that will bring back the element of the vector that is in that position. So in our first function, when we send inventory 0, what I would expect is that this function would return the element of that vector inventory that was at position 0, which should be stored. Okay, so let's go ahead and continue with our main function. Okay, this time we're copying a string object, and this is an expensive assignment because we are sending a copy of that particular object. So this time we define a regular string called str, and we will declare its value to be ref to element inventory 2. So this time when we call our function, we are not getting its return value as a reference. We're getting its returned value as a new string. So it would be a copy of the value rather than a reference to that value. And we'll see out that string followed by 2 line returns. Now, altering the string object through a returned reference. We'll set our str equal to healing potion. We'll send the altered object to cout. So we cout inventory 1. And that is the end of our main function. So let's go ahead and save this. And we can compile it. Hopefully. No, line 37, on line 36, I forgot my semicolon. So let's try it again. There we go. Oh. All right. So first 2 lines, sending the returned reference to cout. Okay, cout calls ref to element inventory 0. And that's what it couts. So in our function, return vec I. Vec is our vector string, which is our inventory vector from our main function. Integer I we sent 0, so it's returning the element at position 0 of our string vector identified as inventory. Our second bit, we assign the return reference to another reference, and we send the new reference to cout. So we define a string reference called rstr, and we set that equal to ref to element inventory, 1. So our inventory vector gets sent as a reference to ref to element, and the integer 1 gets sent to our integer I. We return vec I, so we return our inventory object, our inventory vector object, but what we're returning is the element at position 1. Okay, and that gets stored in our string reference rstr, and then we cout that string reference rstr, and we see that it is armor. Next, we're going to copy that string object returned from our function into the string str. So we send inventory 2. Ref to element returns the element at position 2 of our vector inventory. But in this case, it copies that value into a new string rather than just referring to it from within the function. Okay, with a large object, this would be an expensive assignment because we would be copying that entire object, not just referring to it. Okay, in our last bit of code, we alter the inventory item at position 1, which, remember, would be our armor. So instead of armor, we now have healing potion. Okay, we send inventory 1, we set our STR to healing potion. Okay, our STR we defined up here as a string reference, and it points to inventory 1. So when it returns, basically what that's doing is it is overriding that element. Rather than just returning it, it does return it, but it returns it because this particular reference is a direct reference to that position in the vector. It doesn't just return it, it changes it and then it returns it. So it overwrites armor with healing potion. And then we send that altered reference, that altered object, to cout. So when we actually print inventory 1, the position 1 of our inventory object, it comes back as healing potion. Okay, hopefully that makes sense to you. Basically, that's probably the most confusing part, is this line of code right here. So looking at what Dawson says about this, in your textbook he says, because our STR refers to the element in position 1 of inventory, this bit of code changes inventory position 1 so that it's equal to healing potion. And then we prove that by displaying it with our cout here, inventory 1. Okay. If that makes sense, great. If it doesn't, please let me know, and I will be more than happy to help you better understand that. These concepts start to get a little vague and abstract, but when you actually see them in action, I'm hoping that helps solidify what's happening. If it doesn't, let me know, and we'll work out a time when we can meet and we can hopefully draw on the board or come up with some other way to better explain this and help you understand this concept. The next video, or perhaps set of videos, will use references along with some other concepts that we've learned to generate a tic-tac-toe game that you can actually play versus the computer. So stay tuned for that.